Welcome back. We see various types of graphs and charts in our day-to-day lives. Let us see now the significance of graphical analysis and introduction to commonly used graphs. Graphical analysis plays a crucial role when we do statistical analysis. Graphs are helpful in two ways. First, to provide insight for the analyst into the data under analysis. Second, to summarize the data and illustrate important conclusions while presenting the data results to others. We may be thinking, how a graphical analysis provides insight for the analyst. The exploratory data analysis is the first look at data. We make use of graphical analysis for this purpose, which help in summarizing relationship amongst variables. It provides insight into nature of x's that may or may not control y's. Graphs also help in understanding the source of variation in the data. We can also get to know some characteristics of the data like central tendency, spread and shape. Basically, this kind of analysis helps summarizing the data. Though, the conclusions that are made in graphical analysis should be verified with advanced statistical techniques as well. We are going to cover line chart, pie chart, bar chart, histogram, scatter plot and box plot at this level of training. The type of graph depends on the data demographics. Data demographics comes out of the analysis that we did initially in measure phase, the process maps, fishbone diagram, XY diagram and FMEA. The focus of analysis goes to the top critical x's identified. Since there are various graphical techniques available, it is important to choose techniques which are appropriate for a dataset and provide information that we are looking for. For example, to understand a correlation between two variables we need to use correlation diagram, a line chart or a histogram cannot help in this case. Line chart is one of the simplest form of chart. It is used in showing trends of performances in quality, efforts or other performance measures. Line chart is constructed by joining data points with a straight line. The data points are plotted in a chronological order. It helps in understanding whether a variable under study is going up or down, or maintaining the same performance over a period of time. We can have other variables also for comparison of trend, or a benchmark can also be plotted. Control charts, run charts, time series plot or La variants of line chart. Pie chart is a circular chart which is used to analyze data frequencies or magnitude of the characteristic under observation which divide the circle into parts. It helps in visualizing contribution of every part on the whole set of the data. These charts are easy to interpret and used very commonly in business. Each slice resembles to a slice of pie, that is why these are called pie charts. Another variant of pie chart is the donut chart. When we have to analyze the frequency of attribute data, bar charts can be used. In bar chart we get to see the absolute values of data. Bars can be presented horizontally or vertically. An important type of bar chart is the Perry-2 chart, which is created by plotting the data categories in descending order. Stem and leaf plots are another type of graphical analysis. With frequency histograms, the identities of individual observations is lost in the process of plotting. While in this type of plot, the numerical values are retained and showed on the plot itself. Unlike histograms, we also do not need to decide on the number of classes and class width. Stem is usually the first digit or digits, and leaf is the last digit in the data value. Here is a simple example of stem and leaf diagram. First digit of each number is written as stem and the last digit as leaf. We should note here in this that leaf value can be repeated as observed in the data set, though the stem value is written only once. When we need to establish relationship between two variables, we should use a scatter plot. While analyzing the process, relationship between a controllable variable and a desired quality characteristic is important. This may help in deciding how to set a controllable variable to achieve desired level of output. A histogram is a graphical representation of the data which is summarized in intervals. It is used to assess the shape of the data, whether data is symmetric or not. We can create various charts in Excel and other statistical tools like Sigma Excel. Here we have given an example of how to create a histogram in Sigma Excel tool. We need to go to Graphical Tools, select Basic Histogram, select Data Range and enter the data field, and the tool will create a histogram. A point to note. We should not conclude that data is normal if it is looking symmetric and bell-shaped in a histogram. As discussed in previous lesson, normality of the data depends on various factors like size of the data, and to establish that data is normal, we must conduct further analysis. A box or a box whisker plot has a box representing the central mass of the distribution and thin lines, called whiskers, extending out on either side representing the thinning tails of the distribution. Box plots summarize information about the shape, dispersion and center of the data. It also helps in identifying outliers. Because of its concise nature, it is easy to compare multiple distributions side by side with the help of box plots. So, when we want to quickly determine if two or more distributions are different or not, we can use a box plot. Box plots also help in identifying outliers. If a value is less than mean value or is greater than the max value, they are treated as outliers. We will learn the significance of outliers in the lessons on statistical process control. For now, we should understand that outliers may skew the data to their side, as they are extreme values away from the natural distribution of whole data set. Boxplot helps in getting information on median, Q3 or upper quartile, lower quartile, Q1, and minimum and maximum values. The interquartile range is the length of the box and can be determined by subtracting lower quartile from upper quartile. In Sigma Excel tool or other tools we can easily create a box plot. Here is a sample from Sigma Excel tool. We need to select box plot from the Graphical Tools menu, choose Data and then click OK. In the box plot generated, we can see the median value, outliers and 25th and 75th percentile ranges. To compare two data sets, we can follow the same procedure, and it will generate the output as shown here. Analyze the comparison chart and share with us what inferences can you make. We'll learn more about the box plot, its application in our next level of the training. When there are more than two variables under study, matrix plots are used. Matrix plot is actually a set of individual scatter plots, which have two variable relationship, but all the scatter plots are constructed in a single plot and create a matrix. These separate plots enable to conceptualize the relationship between different variables. The commonly used plots in ANOVA and DOE are main effect and interaction plots. Main effect plots are used to compare magnitudes of main effects of multiple factors on response variables. Response variable are the dependent variables or the Y's as we discussed in the define phase. So when we want to understand the effect of two or more factors on the response variable, we can do ANOVA and analyze the main effect plots. The points in the plots are means of response variable at various level of factors. The overall mean of response data is plotted as the reference line. We will revise and understand more about this type of plot in the lesson on ANOVA later. As discussed on previous slide, the interaction plots are also used in ANOVA and DOE. These are used to visualize the presence of interaction among several factors. We say interaction is present when the response at a factor level depends upon the levels of other factors. When there is no interaction, the lines run in parallel, as we can see in the right-hand side chart. Let us do some exercises. In the workbook you'll find the data on sheet 2.2.4. Create appropriate charts to depict the given data graphically. Now we have come to an end to this subunit on Six Sigma statistics. We learnt about the basic statistical concepts, probability, how descriptive statistics is used to summarize the data, what is normality, how does it influence the statistical analysis. And we also covered various common graphical techniques that are used to analyze the data visually. In the measure phase, So far we have covered process definition and basic statistical concepts required for Six Sigma projects. Next subunit is on measurement system analysis, where we will learn about measuring the robustness of the measurement system so as to get confidence that the data that we are measuring is right and has no influence of external factors. Here we come to an end to this lesson. Should you need any support, feel free to contact us. Thanks for watching this video, and see you in the next lesson.